Okay, for grade 10 mathematics, we are still doing indices. Right, so our first question is about simplify these expressions. So for our a, we've got a squared times a power 3, a cubed. Okay, now when it comes to indices, whenever you are multiplying powers, okay, whenever you are doing a multiplication of powers, say for instance a squared times a cubed. Okay, so the rule of indices says that to multiply powers you add the powers, okay, because this means a times a, okay, this is a squared times a times a times a, which is a power 3. So you can see that here we've got 5 a's altogether, right, which we say a power 5 is the answer. Okay, this is if we are to use the traditional method, but in mathematics there is what we call using rules of indices. Okay, so when you have a squared times a cubed, you simply add the powers and maintain the base. So 2 plus 3 is equals to 5, which is the same as the answer that we had found earlier on. And so in this case, all those like b is about multiplication, you just add the powers. C and D should be easy for you to do now. So I've done A for you, and since E is division, and division I haven't explained, we are going to do question E, which says y power 9 divided by y squared. Now this literally means we've got 9 sets of y's, 3, 4, 5, 6, 7, okay, let me add this side, 8, and then where can I put one more y, and 9 over how many y's? 2 of them, y times y. So when dividing, we know that we cancel the y's. So if we cancel this y out, let me use a rubber. We cancel one y, we cancel one y together with the multiplication. We cancel one y, cancel one y, and the multiplication. Now how many y's have we remained with? This is 1, 2, 3, 4, 5, 6, 7. Okay, so we say the answer is y power 7. So this is a traditional method, but for indices the rule says that when you are dividing you are supposed to subtract the given powers. In this case our answer is just y 9 minus 2, which results in y power 7. Okay, so that's how you do the division for E, meaning you can answer F by yourself, and G is it needs a bit of explanation. So on G we've got, okay, question G, Q inside the bracket power 3 and 4 is outside. Alright, so in mathematics whenever we have a bracket it means we are supposed to do multiplication operation. In this case, since inside the bracket we have got a 3, it means we multiply the power 3 by 4. Okay, now we do know that 3 times 4 equals 12, so the answer is Q power 12, meaning q power 3 in the brackets with 4 outside equals to q power 12. H, you can work it that similar way. I, the similar way. You first find so for I, what you're going to do is to first simplify this from the brackets using the multiplication. That's when you now divide by r power 4 using the answer to that you find here. All right, so far so good. Then k says t squared by t power 5 over t power 3. So just to guide you on this one, we do know that when you're multiplying, you add the powers, right? So here you are going to find t something, some 2 plus 5, okay, 2 plus 5 over t power 3. So we do know that 2 plus 5 is 7, meaning our answer is t power 7 over t power 3. Now, an over in mathematics is a symbol of division. Okay, and we know that when you're dividing powers, you subtract. So in this case, 7 minus 3 gives us what? 4. And our answer is t power 4. So you can use the similar method to work out I. Alright, then and the other questions which are similar, you can do them. Okay, let's look at question number 2. So in this case, for number 2, where we have it says find a when, okay, when 2 power 3 times 2 power a equals 2 power 7. So we're interested in finding what this a stands for. Okay, so what we do is we're just going to pick the powers. So here we'll pick 3. Now we do know that when you're multiplying, you add them, right? So you add these 3 here plus the a, which is here, equals the 7, which is here. So now to find the value, we are going to use inverse. So these 3, we're going to move it to the other side. Okay, so we're going to remain with a here equals 7. Now this 3 is a positive number, so it shall become negative 3. In that case, a equals, what is 7 minus 3? 4. Right, so on a, that's how you calculate the value of a. The correct answer is supposed to be 4, meaning for b you can do the same thing, and c. Then when it comes to d, where there's a division, we are going to work it out like this. So on d we have r power a divided by r power 11 equals r power 9. So similarly, we are going to pick the powers. We'll say a. Now when we're dividing the powers, we are supposed to do what? To take away. So we'd say minus, the other r has got power 11 equals power 9. Alright, then we find the value of a by moving one of the terms or the variables. In this case, we can move negative 11 to where 9 is. Okay, so we shall remain with a equals 9. Now negative 11 has a negative, so it becomes positive 11. In this case, our A equals 20. So for D, that's how you do it, meaning E similar way, F in a similar way, then G has got brackets, but if you remember what we said about brackets, it shouldn't be a challenge. So for G, where we have 3 power 5, 3 power 5, then outside this A equals 3 power 20. Alright, so first of all, we are going to deal with the brackets. Okay, just like BODMAS states, we start with the brackets. So in the brackets, we have a 5, outside we have an A. 5 times A will give us 5 what? 5A equals, then the other side, we've got 20, if we are to pick the powers only. Then, so never mind the base, which is 3. We are trying to find the value of A. That is our question there. So in this case, to find A, we need to find a number that we can divide with, so that we only remain with A. So if we divide by 5 this side, it means we also do the same the other side to balance the equation. So we have put 5 so that we say 5 into 5 1, 5 into 5 1. Then this side we are going to say 5 into itself 1, 5 into 20 4. So what are we remaining with? A equals 4. That is what has remained. So our A in this case is 4 for G, and the similar way applies to H. Then I think we should do I together. It's a bit different. Okay, so on I, we've got x power A, then A plus 1 equals x power 42. So let's work out the brackets. What is A times A? That should give us A squared. Then remember there's plus 1 next to that A. Then equals the power on the other side is 42. All right, so okay, we are first going to move this plus 1 to this side, so we shall have A squared equals 42 minus 1. Then it will become A squared equals 41. Now the rule is, if you have got a square number, then you want to find the other side, you put squares even the other side. So when you put a square here, okay, okay, so let me use a rubber. So to find A squared, since we said that A squared equals to 41, okay, let's use this side. So if A squared equals 41, okay, if we introduce a square this side, it means this side we are not going to have a squared. So our A is going to be equal to, what is the square root of 41? Now you can use a calculator. You are going to find the answer to be 6.40 something something, or so the digits go on. So to round it off to one digit, it will just give us 6. So that is I. So this is an example of an irrational number. Remember 41 is a prime number, but if we round it off we get 6. So that's how you do number 2. Then we move to number 3. Simplify these fractions. Okay, so A says we'll do A, then the rest you can work them out by yourself. So we have got 2x power 8 times, there's a bracket, 6 x power 5 over, we've got 4x power 9. Okay, so we are not just going to deal with the powers because the base is different. Here we have got a 2, here we have got a 6, so we can't maintain the base. Instead we have to multiply 2 times 6 equals 12. Then we put the x, then we do the addition of the powers because there's a multiplication here. So 8 plus 5 is 13, right? So we've got 12x 13 over 4x power 9. Okay, let's write it nicely here. We are saying we've got 12x power 13 over 4x power 9. Now we do know that when this division line here, it means we have to subtract the powers. So 13 minus 9, first of all let's divide 4 into 12. 4 into 12, it goes there 3 times. 4 into 4, 1. Then the powers we have to subtract. So we have got a 3 for the bases. Then for the powers we have got an x. 13 minus 9 is 4. Okay, so this is how you solve if the numbers are different, like in this case. So you can use the same method to answer B and C. Then D, we're going to go through D quickly. We go through D, then we see which ones you can be able to get correct. So for D, we've got open bracket 6a cubed close bracket by 4a power 9 and over, we've got 2a squared in the brackets by 3a power 8. Okay, so similarly the bases are different, so we need to multiply them. 6 by 4, that should give us 24. Then we put a. Now since we're multiplying, so we add the powers. 9 plus 3, that should give us 12 over 2 times 3, that is 6, and an a. Then since we're multiplying, we do 2 plus 8, which would be 10. Now it has turned into division, meaning we do 6 into 6, 1, 6 into 24, it goes 4 times. So for the bases we have 4, and we also have an a. Then to find the powers of a, we do subtraction because there's a division line. So 12 minus 10, that is 2. So that's our answer for a power 2 for D. You can do the same for E as well as F. Okay, then we go to number 4. Simplify these fractions. So for A, we are saying open bracket 4a cubed, then b power 4 close bracket times we've got an open bracket, then 10 a, okay, this 10 is not looking, start afresh, 10 a power 2, then b power 5, okay, over 5 a power 4 and b power 2. Okay, we do know that if the bases are different, we have to multiply them. So we have 4 and 10, meaning 4 times 10, that should give us a 40. Then we work out the a's. What is the value of a? Since we're multiplying, so we do 3 plus 2, which is a power 5. Then the value of b, we have 4 and 5 on the other side. Okay, 4 here, 5 here, which is 9. Then over, what do we have down there? 5a power 4 b squared. Okay, so we can do the division for the base. 5 into 5 it's 1, 5 into 40 it's 8. So the base is 8. Then we deal with a now. We've got a power 5 here and 4 down. So 5 take away 4, that should give us 1, which is we don't even indicate 1 in powers. Then for the b, we've got 9 and 2. So 9 take away 2, that should leave us with 7. So our answer is 8a b7 to the power 7. So we hope that you can do b, c and d in a similar way. Then for number 5, we'll simplify these expressions, and a, we've got open bracket 2x squared y, a 3 is outside. Okay, so we do know that bracket means you multiply. Okay, so 2x has got a squared, so 2 we multiply times 3. 2 times 3, that's 6. Then this y has got nothing, so it's power 1. 1 times 3 is 3, so y is power 3. So this is how you can remove it from the brackets, meaning you do the same for b and c and d, even e and f you remove by multiplying the number outside the bracket. Then for g, let's do g together. Okay, so on g we've got open bracket 2x squared y cubed, and we've got a 4 outside, times 3x squared y cubed, then we've got a 3 outside. So first of all, let's remove from the brackets. Here we've got a 4, so we're going to say 2x, this x has a power 2 here, so 2 times 4, that should be 8. Then the y has got power 3, 3 times 4, that should be 12, times, okay, times, so this part times, we've got 3x, we've got a 2 and a 3 here, meaning 2 times 3, that should be 6. Then for y, since we have a 3 here, 3 times 3, that should be 9. Now we move on to the next stage. Since here we have a 2 and here we have a 3, the base is different, so we multiply it, as in 2 times 3, that should give us 6. Then for the x, we've got multiplication sign over here. Okay, this x is too big. Okay, now this is the x, this not times, right? So for the x, we have got power 8 and power 6. So since we are multiplying, it means we add 8 plus 6, that should give us 14. So x is to the power 14. Then y, now we've got y power 12 here, y power 9. So 12 plus 9, that should be 21. Yeah. Okay, so this is the final answer. 6 x power 14 y power 21. So you can also apply the same method to simplify h. Okay, then we move on to number 6. Calculate the values of these expressions. Okay, so we've got a, which says 2 power 6. So power means you multiply repeatedly. In this case, the 2 should be 6 times. 1 2 3 4 5 6. So 2 times 2, that gives us 4. 4 times 2, that is 8. 8 times 2, that should give us 16. 16 times 2, that should give us 32. 32 times 2, that should give us 64. Therefore 2 power 6 is equals to 64. So you can do B and C and D. Then E is a bit different because it has a negative power. Okay, so I'll try to explain a bit about how to evaluate negative powers. So we have 2 power negative 3. Now think of it like this: 2 power 0 is 1. So you must master at least the 4 negative powers. So 2 power 0 is always 1. Then as we are going to the other side of the number line, after 0 we have 2 power negative 1. This side we have got 2 power 1, but we are looking at negative numbers. So if 2 power 0 is 1, 2 power negative 1 will be half. Okay, because we are getting smaller as we are going. Okay, half. Okay, then 2 power negative 2. This 2, it's like it's been multiplied 2 times, it becomes a 4. So any number 2 power negative 2 is a quarter. Then 2 power negative 3. Okay, so these are numbers you should master by heart. 4 times 2, that would be 8. So 2 power negative 3, the answer is what? 1 over 8. You always start from 2 power 0 is 1, 2 power negative 1, until you at least up to 2 power negative 3 you should know by heart. However, if you want to go by the rules of indices, they state that a power negative 1 means that 1, you write it as a fraction, then a should be down to that power. Okay, so in this case it means that whenever you have such kind of a expression, it means you write it as a fraction, then you write 2 power 3 as a positive. The negative has now gone, there's no negative here. Then you evaluate. This means 1 over, what is 2 come 3 times? 1, 2, 3. It's 8, right? So here it's 1 over 8. So you can use that rule of indices just to make sure that you've gotten the point. We can also try to answer f. Okay, let's try f together. So f says 10 power negative 2. So we say that whenever it's a negative power, you write 1 on top as a fraction. Then 10 will now be a positive. It won't be power negative 2. This therefore means 1 over, what is 10 times 10? That's 100, right? So this means 10 power negative 10 is 1 over 100. If you want, you can also write it as a decimal number. I'm sure you know how to convert. Alright, so you can answer, oh my god, okay, G needs a little bit of some highlighting. So any number to the power 0 according to indices is what? 1. Whenever you have 2 power 0, the answer is 1. Any number power 0 should give you the answer 1. So H you can find, I you can find, then J may need some help. Okay, so J says 1 over 2, then the 3 is outside the bracket. So this means that the power should be shared by the fraction. So 1 over 2, 1 should have a 3, 2 should have a 3. Now, what is 1 power 3? This is like 1 times 1 times 1. Still give us 1. So on top we have 1. Then 2 power 3 means 1, 2, 3, which is 8. So here we've got 8. So the answer to this question is 1 over 8. I'm sure you can work the same way for K and L. Yeah, K, L, they are similar. Then M. Okay, let's may I help you with M a bit. Okay, so for M it says 1 over 2. This time around we have got negative 2 outside the bracket. This means that 1 will share negative 2 and 2 will also share negative 2. Now we do know that a negative number, when you have a power which is negative, it means 1 over that number with a positive square over, okay, this is one part. Then this one will say 1 over 2 to positive power. Then we evaluate now. So on top, what is 1 over 1 squared? We know that this is just 1. Wherever you multiply 1 times 1, it will be 1 over 1. So on top we've got 1. For this part we've got 1. Then down we have 1. Then 2 power 2 is 4. So 1 over 4. So think of this fraction as, this is a division thing here. So it's like 1 divide by 1 over 4. That is what this part means, because this thing here is a division. 1 divided by 1 over 4. So you can write it like this. Now you know how to divide fractions. It simply means 1 times, the 4 goes on top, 1 comes down. Here you balance with 1. Now 1 times 4, okay, let's create some room. We use this side for find the answer. So 1 times 4, okay, you get 4. Then down 1 times 1 is 1. Then 1 into 4, it's 4. Right, so the answer is 4. That is how you so with practice you are going to get used to how negative powers can be solved. So you do the same for N and O. Okay, we move to question 7. So for A, it's saying find x when 32 power x equals to 2. So what we know is that we need to ask ourselves, we need to make the base the same. So what power of 2 can give us 32 so that we have the same base? So we know that 2 power 5 gives us 32. Okay, so we have made the base the same. Now we've also got an x outside here. Then this side, the 2 doesn't have a power, it means it's power 1. Then now, since we want to find the value of x, we'll just pick the powers. In short, we have got 5 times x is 5x equals, this side we have 1. So to find x, you divide by 5, even this side by 5, so that this x will cancel, the 5s will cancel each other, making x equals 1 over 5. So that is x for A. So just to run you through, the first step is to make the base the same, and then you work out the powers to calculate the value of the letter. So for instance, should we do, okay, we'll do B as well to familiarize the concept. So we've got 81 power x equals 3. So we try to make the base the same. Okay, what power of 3? We want them both to be 3. What power of 3 can give us 81? We do know that 3 times 3 is 9, 27, 81. So 1, 2, 3, 4. That means 81 is 3 power 4. Then we do know that there is also an x here. Then here there is nothing, meaning it's 1. Okay, here there is an x, not a 4. There is an x. Okay, now picking powers only, we've got 4x equals 1. So what is x? You divide by 4, you divide by 4. So x x in this scenario, okay, these cancel each other, so x in this scenario is 1 over 4. So use the same method to answer C, D, E, F, G, H. Okay, then I is a bit different, which means we need to do it together. Okay, so for I, where we've got, it says okay, this is I, 3 power x is equals to 1 over 3. Now let me remind you that according to the rules of indices, a power -1 means that the number is a positive fraction like this. So this is a positive fraction, it means it came from this form. Now what is this form? This form can be 3 power -1. So the 1, if you want to write it from fraction form, you just write 3 power -1. Alright, so that's what this means. So we are saying that to write 1 over 3 with a power, okay, because 1 over 3 is quite hard to find, so we are saying 3 power x is equals to 3 -1. Okay, now the base are same, only that we have worked from the right side. Now to find what x mean, we are saying x equals -1. So since the base are already correct, so our answer here is -1. Okay, it's just a matter of knowing what 1 over 3 means. It means 3 power -1. Just like that, we've answered. So we'll also try J to familiarize with the concept. For our J, it says 81 power x equals 1 over 3. So we are saying that, okay, let's write a fraction there with a power. So 1 over 3 means 3 power -1. Okay, this is according to a power -1 means 1 over a. This is the row of indices. Okay, so since we've got this, but the base are not the same. I'm sure I remember that 3 power 4 is 81. So let's make the base the same. 3 power 4 equals 3 power -1. So we are saying that there's an x there. Okay, let's create some space just over here. Okay, do it once more. So we're saying that 3 power 4 is 81. Now remember that there's an x here, right? Equals, here we have got -1. Okay, and 3. So if we pick the powers only, we've got 4 times x is 4x equals -1. Now how do we find x? We divide by 4, we divide by 4, meaning x equals to -1 over 4. So the answer here is x equals to -1 over 4. Alright, so that is how you solve that particular question for indices. So I want us to try the one with 5. So the one with 1 over 5k, it simply means 5 power -1. Then you make the base the same. 1 over 2 means 2 power -1. You make the base the same, just like that, and you are done. Right, then for the final one, which is question 8, evaluate these expressions without using decimals. Show all your working clearly. Okay, so for A, we've got 3 power -4. Now we do know by now that when you have a negative power, it means you write it over, 1 should be on top, then the power will cease to be a negative, like this. And then we do know that 3 power 4 is 81, so it becomes 1 over 81. Then we can't divide into decimals because it says without using decimals. Okay, so the answer is 1 over 81 to A. B, you can do the same thing. You just remove the negative by making it a fraction of 1. And then for D, which is saying 8 power, this should be a smaller power, 8 power 1 over 3. So whenever you're dealing with a base raised to a power of 1, it means cube root of this 3 comes outside, the 8 goes inside. Okay, this is what it means when you say, then the 1 which is on top, it comes to the base, so this becomes the power of 8, the 3 outside the square root. This is how you transform fraction powers into the square root, in this case the cube root, because there's a 3 there. So now you ask yourself, which number can we multiply 3 times to get 8? That's what cube root means. So if we do which number can we multiply 3 times? This is 4. Okay, so the cube root of 8. Okay, then 2 times 2, this is 4. 4 times 2, this is 8. So the answer here is 2, because the cube root of 8 is 2. Okay, so it's a matter of knowing how to change into a square root. Then if you look at a further example, so e is a bit different. It's not 1 over 3. E is saying 16 3 over 4. So remember what I said, you change into the square root, 16 comes inside. Then this number which is down comes outside the square root. Then the power which is on top goes to 16. Now we can evaluate, since we have simplified things. So ask yourself, what number can I multiply 4 times to get 16? So if you try 2 times 2, 4. 4 times 2, that's 8. 8 times 2 is 16. So the missing number there is 2. Now it is being raised to power what? 3. Meaning, what is 2 power 3? Which is 8. We know that. So the answer to E is 8. I'm sure you can do F the same way. I'll leave F for you. Then for G, which is saying 3 over 4 in brackets raised to power 2. This means that both the numerator and denominator will share the 2. So it will be 3 power 2 over 4 power 2, which is 3 times 3, that's 9. And 4 times 4, that's 16. Okay, that's for the that one. Okay, then we move on to, so the answer is 9 over 16. We move on to H. H is a bit different. We've got 27 over 64, right? Now this time they are sharing a fractional power. This simply means that 27 will have that power, and 64 will also share that power. Now remember what we said about square roots. This number comes outside, right? Then 27 will be inside. Okay, 27 will be inside to the power 1, which is 3.7. Then down we'll have 64. This 3 which is here down comes outside, the 1 goes inside. Now we can we have a division line. So which number can you multiply 3 times to get 27? We do know that 3 times 3 is 9, times 3 is 27. So on top we have got a 3. Now down, what number do you multiply 3 times to get 64? Let's try 4. 4 times 4 is 16. 16 times 4. What's 16 times 4? 6 times 4 is 24. Okay, let's try if it will work out. 16 times 4. Here you're saying it's 24. Hey. Okay, 4 carry 2. 4 times 1, 4, 5, 6. Okay, so it is 4. When you multiply 4 4 times, it gives you 64. So it's 3/4. Our answer for that is for H. So I'll leave I for you to do by yourself. Okay, so this is where we come to the end. Make sure you do go through all the questions. It takes about 2 days. You go through it today, and then tomorrow you begin to understand how they work. All right, see you. Bye bye.